Correlation, section 9.1. We are going to learn linear correlation, independent and dependent variables, and the types of correlation, find a correlation coefficient, and distinguish between correlation and causation. So correlation is a relationship between two variables. The data can be represented by ordered pairs x and y, where x is independent or explanatory and y is dependent or response. A scatter plot can be used to determine whether a linear straight line correlation exists between two variables. For example, if we were to plot this data, we would get this graph as a result, and there is a linear correlation that it does exist. We can use Excel to plot that ourselves. So what you would first need to do is type your data into Excel, highlight your data, insert a scatter plot, label your graph, and then you are complete, and you will see if there's any correlation that exists. So I'm going to go to Excel right here. I've already inputted the data. I'm going to highlight my data, go up to Charts, go under Scatter, and I'm going to do Scatter with the markers. And then I need to change the format of my scatter plot so that I can label it. And there I can see that there is a linear correlation, in this case a positive linear correlation, and I'll cover that in just a little bit. So I also need to change my graph. In this case, it's really just going to be like x versus y, because there really is no context to this problem. And this would be my x data values, and this one, the y-axis, would be my y data values. And then I have completed a scatter plot. So now I'm going to go back to our example over here and continue on our PowerPoint. So, types of correlation. We can have a negative linear correlation, and that is as x increases, y tends to decrease. A positive linear correlation, as x increases, also y increases. No correlation at all means nothing exists, and a nonlinear correlation. In this class, we're going to be dealing with negative linear and positive linear correlations. So, a marketing manager conducted a study to determine whether there is a linear relationship between money spent on advertising and company sales. The data are shown in the table. Display the data in a scatter plot and determine whether there appears to be a positive or negative linear correlation or no linear correlation at all. Alright, so this is the scatter plot that we got out. There appears to be a positive linear correlation, and we would consider this to be somewhat strong, but not as strong as the other linear correlation that we found because it went straight up. And I'll discuss that a little bit more later. So, correlation coefficient is a measure of the strength and direction of a linear relationship between two variables. The symbol R represents the sample correlation coefficient. This is the formula for calculating R. We will not do that in this course. We are going to use Excel to calculate that for us. The population correlation coefficient is represented by rho. And we're going to use Excel, like I said, and you type in Correl, and then you put your data from the x values in, comma, data from the y values, and then you end it. So the range of correlation coefficient is -1 to 1. So if it's -1, there's a perfect negative correlation. If it's at 0, there's no correlation. And at 1, there's a perfect positive correlation. Anything really close to 1 we would call really strong, and anything really close to -1 we would call really strong as well. The negative and the positive doesn't have anything to do except for the direction and the value of R. Just because it's negative, all we care about is that it's close to -1. If it's negative close to the 0, it's still not any good, just as a positive close to the 0 would not be any good. So for this one, -0.91, there's a strong negative correlation because that is close to -1. Here, 0.88 is also a strong positive correlation. If we have 0.42, that is what we considered weak. So that's below 5, so we're going to say that that is a weak correlation. And if it's at 0.07, there's just no correlation at all, because you can't really tell if it's going up or it's going down. So here's another example that I have put into Excel. We're going to type in the data, highlight the data, click Insert Scatter Plot, graph the data, and then we're going to use Correl to find R and tell if it's a strong or not or weak linear correlation, or if there's no correlation at all. So over here, I'm going to highlight my data, and then again I'm going to go up here to Charts, Scatter, and do a scatter plot. Now, as I notice here, they seem to be a positive correlation. So let's look at R to double check and make sure. So I'm going to go up to D1 in my case and put equals CORREL, parenthesis. I'm going to highlight my data for array 1, comma, and then highlight my data for array 2. And then I'm going to close parenthesis and hit enter. And it's going to give me R value of 0.978. That is a very good, strong, positive linear correlation. And here you can see it's also on the PowerPoint as well. So to calculate the correlation coefficient for the advertising expenditures and company sales data, what could we conclude? So R was 0.913, which suggests another strong positive linear correlation. Alright, so a causal relation between two events exists if the occurrence of the first causes the other. A lot of people get correlation and causation mixed up. Alright, but the first event is called the cause and the second event is called the effect. A correlation between two variables does not imply causation. That is very important. Just because two things are correlated does not mean that one caused the other. If there is a causal relationship between the two variables, then they must be correlated. So this is like a square is a rectangle, but a rectangle is not a square kind of situation. If there is a causal relationship, it must be correlated. If it's correlated, does not mean we have a causal relationship. So first, some examples of causal relations. Example 1, a study shows that there is a negative correlation between a student's anxiety before a test and the student's score on the test. But we cannot say that the anxiety causes a lower score on the test. There could be other reasons. The student may not have studied well or any other thing. So this correlation here does not imply causation. However, consider the positive correlation between the number of hours you spend studying for a test and the grade you get. Here there is a causation as well. If you spend more time studying, it results in a higher grade. Correlation and causation. If there is significant correlation between two variables, you should consider the following possibilities. Is there a direct cause and effect relationship between the variables? Is there a reverse cause and effect between the variables? Is it possible that the relationship between the variables can be caused by a third variable or something we don't know of? Or is it possible that the relationship between two variables may be a coincidence? So these are some questions you can ask yourself to figure out correlation and causation. That is section 9.1, an introduction to linear correlation, independent and dependent variables. We found a correlation coefficient, and we distinguished between correlation and causation.